Earth's atmosphere is our planet's invisible shield, a thin, dynamic blanket of gases that makes life possible. It filters out harmful solar radiation, incinerates meteors before they reach the ground, and moderates temperature extremes. The greenhouse effect keeps our world warm enough for liquid water, while the atmosphere's constant motion redistributes heat and moisture, creating weather and climate. This swirling ocean of air delivers rain, shapes landscapes, and sustains every ecosystem. Though we rarely notice it, the atmosphere is the silent guardian of life on Earth. It is the very heart of our planet's climate system. Every breath we take, a seemingly simple act, is in reality a profound connection to the world around us. It's a testament to the intricate systems that have evolved over millennia to support life as we know it. Consider the mechanics of breathing, the expansion and contraction of our lungs, the intake of vital gases, and the expulsion of waste. It's a rhythmic dance, a constant exchange between our bodies and the atmosphere. Is a blend perfected over eons, a precise mixture of gases, each playing a crucial role in the grand scheme of things. This isn't just any random assortment, it's a carefully calibrated concoction, fine-tuned by the forces of nature over vast stretches of time. The very air we breathe is a product of planetary evolution, a testament to the Earth's capacity to nurture and sustain life. Mostly nitrogen, an inert gas that makes up the bulk of our atmosphere, which supports life's building blocks, forming the foundation for proteins, DNA, and countless other essential molecules. Nitrogen's role is often overlooked, but without it, the very fabric of life would unravel. It's a silent guardian, a stable presence that allows other, more reactive elements to flourish. And oxygen, the fuel for our bodies. This life-giving element powers our metabolism, allowing us to extract energy from the food we eat. It's the spark that ignites our cells, driving every movement, every thought, every breath. Oxygen is the engine of life, the driving force behind our existence. Oxygen's presence is a legacy of ancient photosynthetic organisms, the pioneers of life on Earth. These microscopic marvels, like cyanobacteria, harness the power of the sun to split water molecules, releasing oxygen as a byproduct. That transformed our planet's chemistry, paving the way for the evolution of complex oxygen-breathing life forms. Their tireless work, spanning billions of years, has shaped the very air we breathe, creating the conditions for our existence. It's a debt we can never fully repay. Trace gases like argon, an inert noble gas, and carbon dioxide, a greenhouse gas vital for plant life, though small in amount, play outsized roles, influencing everything from temperature regulation to plant growth. These seemingly insignificant components are the unsung heroes of our atmosphere, working tirelessly behind the scenes to maintain the delicate balance that sustains life. Carbon dioxide regulates temperature, trapping heat and preventing our planet from freezing over. It acts like a blanket, keeping us warm and cozy in the vast expanse of space, and powers photosynthesis, the process by which plants convert sunlight into energy, releasing oxygen as a byproduct. It's a beautiful cycle of give and take, a symbiotic relationship between plants and animals that has shaped the course of evolution. Water vapor, ever-changing, a dynamic component of our atmosphere, drives the water cycle and weather, shaping landscapes and influencing climate patterns across the globe. It's the lifeblood of our planet, the source of all rivers, lakes, and oceans. The air also carries aerosols, microscopic particles suspended in the atmosphere. Tiny particles from dust carried on the wind from distant lands, pollen, released by flowering plants to propagate their species, sea spray, tiny droplets of salt water that evaporate into the air, and pollution, byproducts of human activity that can have detrimental effects on air quality and human health, that seed clouds and influence climate, playing a crucial role in the formation of precipitation and the distribution of heat around the planet. Each component, no matter how small, is vital to the balance of life. It's a delicate dance, a complex interplay of forces that sustains all living things. Disrupting this balance can have far-reaching consequences, threatening the health of our planet and the well-being of future generations. The atmosphere is a living recipe, constantly evolving and adapting to the changing conditions of our planet, sustaining every breath and every ecosystem, a testament to the power and resilience of nature. It's a gift we must cherish and protect, ensuring that future generations can continue to breathe freely and thrive on this beautiful planet. The atmosphere is layered, each stratum with its own story. The troposphere, where we live, holds most of the air and all weather. Above, the stratosphere contains the ozone layer, shielding us from ultraviolet rays. The mesosphere burns up meteors, while the thermosphere hosts auroras and satellites. Temperatures rise and fall with altitude, creating distinct boundaries. Beyond, the exosphere fades into space. These layers together form the protective shell that makes Earth unique. Air, the very essence of life, surrounds us constantly. It may seem weightless, an invisible and intangible presence that we often take for granted. We breathe it in, we breathe it out, without truly considering its properties. But the air around us is far from being an empty void. In reality, it presses down on us with immense force, a silent, constant pressure that we've evolved to live with. This force, known as atmospheric pressure, is the result of the weight of all the air molecules above us, constantly colliding with everything on the Earth's surface. At sea level, this pressure is substantial, amounting to over 1 kilogram per square centimeter. Imagine the weight of a small car pressing down on every inch of your body. That's the kind of force we're constantly subjected to, without even realizing it. As we climb higher, into the mountains or even just a tall building, things begin to change. The air pressure and density drop rapidly, there's less air above us, and the molecules are spread further apart. This thinning of the air has profound effects on our bodies and the environment. The reduced oxygen levels at high altitudes make high-altitude survival a challenge, requiring specialized equipment and careful acclimatization. Mountain climbers often rely on supplemental oxygen to combat the effects of thin air. But pressure isn't the only atmospheric property that changes with altitude. Temperature changes with altitude are complex, governed by a variety of factors. In the troposphere, the layer closest to the Earth's surface, temperature generally falls as altitude increases. This is why mountain peaks are often capped with snow, even in the summer. However, this trend reverses in the stratosphere, where temperature rises with altitude due to the absorption of ultraviolet radiation by the ozone layer. As we move further away from the Earth's surface and into the mesosphere and thermosphere, temperature shifts again in higher layers, creating a complex thermal structure. These patterns drive weather, the constant dance of air masses, moisture, and energy that shapes our daily lives. Warm air rises, becoming less dense and creating areas of low pressure. Conversely, cool air sinks, becoming denser and creating areas of high pressure. And pressure differences create wind, as air rushes from areas of high pressure to areas of low pressure, seeking equilibrium. The interplay of pressure, temperature, and density is a fundamental aspect of atmospheric science. This complex interaction powers the global engine of weather and climate, influencing everything from daily forecasts to long-term climate trends. Every breeze and storm, from the gentlest whisper of wind to the most violent hurricane, is born from these invisible forces, the constant push and pull of pressure, temperature, and density. The atmosphere's weight and warmth, its dynamic interplay of forces, shape the world we know, influencing everything from the landscapes we inhabit to the very conditions that allow life to thrive. Look up. What do you see? The sky's blue, a seemingly simple observation, but one that holds a universe of scientific wonder. It's a color we often take for granted, a backdrop to our daily lives. But have you ever stopped to consider why the sky is blue? What makes it that particular shade? And what role does the atmosphere play in this beautiful phenomenon? The answer lies in the way sunlight interacts with the air molecules that make up our atmosphere. Sunlight, which appears white to our eyes, is actually composed of all the colors of the rainbow. As this sunlight enters the Earth's atmosphere, it collides with these tiny air molecules. This collision causes the sunlight to scatter in different directions. This scattering is sunlight scattered by air molecules, a process known as Rayleigh scattering. Now here's where the magic happens. Blue light has a shorter wavelength compared to other colors in the spectrum, like red or orange. This shorter wavelength means that blue light is scattered more effectively by the air molecules. Rayleigh scattering sends blue light in all directions, creating the blue sky we see. It's like the atmosphere is a giant disco ball, scattering blue light all around us. But what about those breathtaking sunrises and sunsets when the sky transforms into a canvas of fiery hues? At sunrise and sunset, the story changes slightly. During these times, the sun is lower on the horizon, and sunlight has to travel a much greater distance through the atmosphere to reach our eyes. This longer journey means that sunlight travels farther through the atmosphere, encountering even more air molecules along the way. As the sunlight traverses this extended path, the blue light is scattered away even more intensely, scattering away blue light. This leaves the longer wavelengths, like reds and oranges, to dominate the sky, and leaving reds and oranges to paint the sky in those warm, vibrant colors we so admire. The presence of particles in the air can also influence the colors we see. Dust and pollution can intensify these colors, adding depth and richness to the sunset palette. These particles scatter light in a more complex way, leading to even more dramatic displays. But the atmosphere's role extends far beyond just scattering light. The atmosphere also absorbs and reflects sunlight, playing a crucial role in regulating our planet's energy balance. For example, the ozone layer in the stratosphere absorbs a significant portion of the sun's ultraviolet (UV) radiation. This ozone blocks harmful UV rays, protecting life on Earth from its damaging effects. Furthermore, gases like water vapor and carbon dioxide in the atmosphere trap heat, creating what we know as the greenhouse effect. And let's not forget about clouds. Clouds reflect sunlight back to space, influencing Earth's albedo and overall temperature. This intricate dance of light and air, absorption, reflection, and scattering governs Earth's temperature and climate, shaping the world we live in. Imagine a world without an atmosphere. Without the atmosphere, our sky would be black, like the void of space. The absence of this protective layer would render life as we know it impossible, exposing the surface to extreme temperatures and harmful radiation. So the next time you gaze upon a blue sky or a vibrant sunset, remember the incredible journey of light through air. Light's journey through air shapes every day and every living moment, a constant reminder of the intricate and beautiful processes that sustain life on our planet. The sun powers a global circulation system, heating the equator more than the poles and setting air in motion. Warm air rises at the equator, cools and moves poleward, while Earth's rotation twists these flows into complex wind patterns. 3 major circulation cells in each hemisphere drive trade winds, westerlies, and polar winds. This movement redistributes heat, making much of the planet habitable. Air currents also drive ocean currents, linking atmosphere and sea in a single climate engine. The restless motion of air shapes weather, climate, and life everywhere. Earth's first atmosphere was hydrogen and helium, soon lost to space. Volcanic eruptions built a second, thick with water vapor and carbon dioxide. No oxygen yet. As Earth cooled, oceans formed and carbon dioxide dissolved, leaving nitrogen dominant. Life changed everything. Cyanobacteria began photosynthesis, releasing oxygen. Oxygen built up, triggering the Great Oxygenation Event, catastrophic for some life, but paving the way for complex organisms. Over time, the ozone layer formed, shielding life and enabling biodiversity to flourish. The air we breathe is the product of billions of years of planetary transformation. In just 2 centuries, humanity has altered the atmosphere more than any force since ancient times. Burning fossil fuels has driven carbon dioxide to levels unseen in hundreds of thousands of years, intensifying the greenhouse effect and warming the planet. Pollution from industry and vehicles creates acid rain, smog, and health hazards, while chemicals like CFCs once threatened the ozone layer. These changes ripple across the globe, affecting weather, ecosystems, and human health. Yet, international action like the Montreal Protocol shows we can repair some of the damage when we act together. Our choices now shape the future of our atmospheric shield. The atmosphere is our common inheritance, a fragile, life-sustaining veil that connects all living things. Human activity is pushing this system into uncharted territory, with consequences for climate, biodiversity, and society. But knowledge gives us power. We understand the causes of change and have the tools to act. The success of the Montreal Protocol proves global cooperation can heal even planetary wounds. Protecting the air means rethinking energy, reducing emissions, and valuing the sky as a shared resource. The atmosphere knows no borders. Its care is a responsibility we all share. The future of our world depends on the choices we make today.